5.5 in your textbook, page 295. Parallel and perpendicular lines. We've already talked about this a little bit. I know it came up in the last test actually, when two lines are parallel. That means that their slope is the same, but we're going to review it today. The goal is to determine and apply properties and equations of parallel and perpendicular lines. So there's a bit of an investigation on the front page, but we're just going to start with the first example. It's pretty straightforward. It says determine which lines are parallel and which are perpendicular to this line. Okay? So what might be the first thing we want to do with this line? What's the first thing we want to do, Austin? Right. The first thing we want to rearrange this to look like this. And Daniel, why might we want to do that?
To isolate for to see the slope, to see if they're parallel or not.
Yeah, exactly. To see the slope. That's the real reason, right? So we want to see what the slope is. So we're gonna rearrange this equation. So doing that, I have negative 2y is equal to 4 minus x. Now solving for y, I'm going to divide everything by negative 2, so that will give me y is equal to negative 1/2 minus 1 over 2. Okay, and now just to rearrange these two numbers so it looks proper. That's our equation. Okay.
Sir?
Yeah.
You see when it's perpendicular, it like flips, right?
Yeah. We're going to talk about when it's perpendicular. Did I make mistakes, Helen?
You should, negative 1 over 2, x is supposed to be negative 1 over 2, and 1 over 2 positive, because you're dividing negative 2.
Thanks. Negative 1 divided by negative 2. Positive 1 over 2. Thank you.
Sir?
Yeah.
You also wrote it x 2y equals negative x plus 4.
No.
Oh, you couldn't have done that?
No, you're right. The equations would have been equivalent, but we don't want 2y on one side. We only want y. Okay?
Yeah, I know, but like when you're rearranging it, for the first step,
You could have, yeah.
because x comes first.
Yeah, but you want to solve for y at the end.
Yeah,
Okay?
the same way.
Yeah. All right, so now that we have the equation that we're comparing to in the format we like, what's the slope here? Notion? Good, it's 1/2, and the y-intercept, Noah? Negative 2, good. So, we need to determine now if either of these three lines are parallel and perpendicular. Okay, and I give you a big hint here. If it's parallel, it means the slopes we've talked about are the same. If it's perpendicular, the slopes are a negative reciprocal. All right, we're going to talk a little bit about what that means in a minute. But basically, you're taking the slope and you're flipping it and changing the sign. Okay? So if you have a whole number and you want to flip it, remember a whole number is just over 1. So then it just becomes 1 over that whole number. All right? So that's what a reciprocal is. And the negative reciprocal is you change the sign. Okay? You're multiplying it by negative 1. All right, so let's see. This one is nicely set up. We already have everything beautiful in y equals mx plus b. So Kevin's going to tell us what's the slope here.
Slope is 2 over 1.
Not 2.
Negative 2.
Good, negative 2. Okay, so when we're trying to determine whether parallel or perpendicular, we actually don't care about the y-intercept. We just need to know about the slope. Okay, so in this case the slope is negative 2. In our case the slope is 1/2. All right, so can you see a relationship there, Kevin? How does 1/2 relate to 2, negative 2? Let's take I just spoke about it, the negative reciprocal. So good communication question here. It's a word that we don't see every day. Negative reciprocal. Yeah, Michael.
Perpendicular?
Yeah, it's perpendicular. And why? Because this negative 2, Kevin, is actually over 1. So when we talk about negative reciprocal, we flip them, so it's 1 over 2. And we change the sign from negative to positive. Okay? So you can see then the negative reciprocal of negative 2 is 1/2, which is the same as our original line. Okay? So because these slopes are negative reciprocals, we know that this line is perpendicular to this line, to the original line. Okay? And if anybody doesn't quite remember what perpendicular it is, it's when there's a 90-degree angle between the lines. Okay, so this is perpendicular to this. Okay? Any questions about that? Perpendicular, straight across. So you could have a line on an angle, and perpendicular would be, again, with a 90-degree angle. Okay.
So the number has to be negative for it to be a positive slope? Like, you always have to do negative reciprocal, you can't just do like a positive reciprocal?
No, always negative reciprocal. So if this was a negative 1/2, how I had it originally,
Yeah.
this would have had to been positive 2. Okay? Yeah.
Sir,
Yep.
only the intercept doesn't matter. The y-intercept doesn't matter. Only the slope.
That's right. So just to go into Daniel's question a little bit more, if you think about it, right? So here's a graph. You're going to have either positive or negative slopes, right? A zero slope is a horizontal line, right? But otherwise, if it's not a zero slope, it's going to be either positive or negative, right? So you can have different variations of a negative slope, this, like this, right? In order for two lines to be perpendicular, you have to have one having a positive slope and one having a negative slope. Does that make sense?
Yeah.
There's no way I can draw a perpendicular line to this with a positive slope. Okay, as soon as I draw a perpendicular line, it now has a negative slope. It's going down. Makes sense. You can't have two lines that are pointing up that are perpendicular. You gotta have one that actually goes all the way over to the other side, right? So that's why it always has to be negative reciprocal. Okay. All right, let's check the next one. Again, they have it all laid out nice for us. Or sorry, right here. They have it laid out very nice. The only difference here is that they haven't reduced this term. Okay, all I did was I canceled the 2 4s into 1/2. All right, so then looking at this, we can see that our slopes are the same. So in this case, the lines are parallel. Any questions there? No, parallels arguably being easier. Finally, the last one. Again, it's in the nice format that we like, so we can see our slope. We can see that our slope has no relation at all to our other slope. First of all, they're both positive, so right away I know they can't be perpendicular. The only other option is that in this particular question is if they're parallel. In this case, they're not the same, so they're not parallel. So this line is not parallel, not perpendicular. Okay, any questions there? All right, moving on, example number 2. All right, so this example, they give us a graph and they give us all these points on the graph. So I've roughly graphed it here. Okay, I didn't graph it accurately. I just gave us a rough sketch. And then what I did was I listed the points, okay, for each one of these. So A is -7 plus 4, so A is here. B is 2 plus 10. M is -5, 0, all right, etc. So they got these points from the graph. They looked at the graph, they found out where the points are, and they came up with this. Okay? The question reads, which line segments are perpendicular? All right? So you can look at the graph right away and you can see the only one that really is under consideration would be what? David?
QP.
Right. You can see that these two are the only ones that are really under consideration. Although you could think of QP and AB being under consideration, because remember, in these formulas for a line, these lines keep going, they keep extending. Okay, there's been no boundaries set on these. So you have to imagine that these lines continue. So you might also want to consider QP and AB. All right? So you might argue, well, sir, I can just look at the graph and I can tell you if they're perpendicular or not. Sure, maybe you might be able to, but you still need to show the algebra. Okay, so don't tune out here. You need to show these steps. Do you know what I'm saying?
Sir, you see how if it's a line, don't they have to be arrows instead of dots though?
Right here?
Yeah.
Here?
Yeah, you see how you put dots, right?
These?
Yeah.
Yeah. Good.
I mean, no, like, you see for AB, I mean, there's like dots at the end.
Yeah, this is just to call out the specific points they gave
Oh,
us. That's all. Alright, so what we'll do is we'll just check all of them. Okay, so the first thing we do, we need to check the slope of each one of these lines. So checking the slope of AB. So here's my 2 points AB. I'm going to check my points A and B here. So I'm going to minus the y's, so 10 minus 4 over 2 minus negative 7. So you get 6 over 9, which is 2 over 3. I'm going to check the slope of MN. So we have 8 minus 0 over 5 plus 5. MN. One thing you can do is, if I got both positive values, just make sure these are positive slopes. Yes, it's pointing up, it's positive, it's pointing up, positive. QP, I should get a negative slope here now. So MPQ. So again, using y2 minus y1, so 3. It's the same thing, I just move the negative sign in front or up to the numerator for syntax. Alright, so we can see here that nothing is parallel or perpendicular to AB, but if we look at MN and QP, we do find out in fact that they are negative reciprocals. So these two here are negative reciprocals. So what that means is, and this is how you would write it, here's the terminology, MN is perpendicular to QP. Okay? Any questions? Example number 3. It says determine the equation that is parallel to this line, that's a negative sign, to this line, and passes through this point. Alright, so this is a little different. Michael, what do you think the first thing, Michael at the very back, last row, what do you think the first thing we're going to want to do is? You're right, yeah, if this wasn't given to us already in y equals mx plus b, that would be the first thing. But it's already given it to us like that. Okay? So it says determine the equation that's parallel to this and passes through this. So, yeah. Good. So you're going to start off, okay, it says determine the equation. So we know that our equation has to look like this. Good, right? So Michael, what Michael told us was that we want to use this point and sub in for y and x. That's good. What am I going to put in for slope here? Yeah, exactly. And we know that because it says it's parallel. Careful, if it said perpendicular, we'd put in the negative reciprocal, right? But it says parallel, so I know that my new line has this slope. Okay, so my slope is in. Now, really, the only thing that's holding me back is the y-intercept. I don't know the y-intercept quite yet. And we've learned in previous sections now. How do I find the y-intercept again, Nicholas?
Put x is 0.
Sorry, yeah, that would be how I'd find the y-intercept. How do I find the y-intercept for this particular equation with b here? If I put x equals 0 here, I'm going to have y equals b. So you're right, that will give me the y-intercept, which is b, but how do I solve for b? It passes through this point. Mark.
You use the x would be 14 and the y would be 9.
Yeah. Michael told us, right? Are you listening? Told us just a little earlier. He said sub in 9 for y and 14 for x. And then using that information we can solve for b.
Oh.
Alright, we've done this in previous sections, right? So we have 9 is equal to 14 goes into 7 twice, so I'm left with 2 on the numerator. Everybody can see that? So this becomes negative 4. Everyone's okay with that? If not, you can always use your calculator and get that same answer, but you should be familiar by now how to make those divisions. So then we have b is equal to 13. So b is 13. Remember, I go back. This is from yesterday. My final equation is okay? All right, Michael Sacchetti. Find the equation of a line that is perpendicular to y equals 3x plus 1 and has the same y-intercept. So what's the first thing we want to do? What do we always do first in these problems? We know the equation, right? Is what?
Y equals mx.
Good, yeah, that's how we always start these. So that's what we're going to start off with. So we want to find this equation of the line that's perpendicular to this. So what's the slope of our new line going to be, if that's the slope of our old line? No? Carlson.
Negative 1 over 3.
Right, it's perpendicular. We talked about this. So, Michael, it's a negative reciprocal of this. So if this slope is 3, in negative reciprocal, you're going to flip it. So it becomes 1 over 3 negative. Okay? So our slope for this then, m is going to be negative 1 over 3. So y is equal to negative 1 over 3, x plus b. Now how do we find b? Josh.
Oh, wait,
We don't have a point to plug in, so how do we find b?
Yeah, got it.
Come on, guys. Noah. Come on, Ryan. You guys are asleep. Did you read the question, Ryan? Can you read it out loud?
Find the equation that is perpendicular to y equals 3x plus 1 and has the same y-intercept.
So what's b?
What?
Come on, guys. Wake up. Notion, what's b? 1. Thank you.
So there you go.
It's not always that hard when I ask the question. If you're listening, it's easy, right? It says the same y-intercept, the same one. Well, what's the y-intercept? It's right here, okay? All right, in summary. Almost done here. The slopes of parallel lines are equal. So that means their m are both the same in both equations. I should say, actually, in summary, first step is always to rearrange equation to y equals mx plus b. Always your first step. From there, you can kind of work it out, right? But until you take that first step and rearrange, we don't have much information about anything. Okay? Any questions? All right, that's the end of the lesson. Oh, sorry. Last part. The slopes are perpendicular if they're negative reciprocals, and we have 2 examples of negative reciprocals. We've talked about it a lot. The only trick maybe that you haven't seen yet, you flip it, and you put a negative sign, becomes positive. If it's positive, it becomes negative. If it's a whole number over 1, you flip it. Okay? If it's a decimal, all right? If it's a decimal, let's say it's 1.235. Okay? This is going to be equal to 1 over 1.235 negative. Don't show me this on the test, because you don't put decimals and fractions. Do this on your calculator. So you're going to get another decimal, right? Okay? So negative reciprocal of a decimal will be another number, right? And it's going to be 0 point something. Okay? Don't show decimals within rational expressions.
So what do you put in the calculator?
You put 1 divided by this.
Oh, 1 divided by.
Equals, and you'll get a decimal.
Yeah.
Okay? Okay, there's also a negative there's a reciprocal button on your calculator that looks like that. You can press that too. Okay, so you press 1.235, press that button, it'll give you 1 divided by, you have to add a negative. Alright, thanks.